Hey guys, we're in Unit 8, and this is day 2, and we're going to multiply radicals today. In our warm-up, it says that the ratio of similarity of triangle cat to triangle dog is 1 to 2. All right, so we're going to go ahead and draw a triangle cat. And we're going to draw a triangle dog because it goes with the 2. It's going to be twice as big for the sides. All right, and then it tells us that CA is x plus 4. And that DO is 3x plus 6. And they want us to find the length of DO. And so we know DO is already longer than CA. And because DO is twice as long, it's going to take 2x plus 4s to equal a 3x plus 6. And now that we have our equation, we can go ahead and solve it. So this is going to give us 2x plus 8 equal to a 3x plus 6. Subtract 2x. And we end up with 8 equals x plus 6. Subtract 6. And x comes out to equal 2. But they want us to find the length of DO. And so now we got to go to DO's expression and plug in. So this is 3 times 2 plus 6, which is 6 plus 6, which is 12. So we can say DO equals 12. All right, if we plug in here, this would be 6. And so you can see that 6 to 12 is the same thing as a ratio of 1 to 2 if you simplify it. All right, so we're going to simplify or multiply radicals today. In order to do that, we do not simplify them first, okay? Just like with terms that aren't like, if we multiply them, something like this, we can multiply those. We can't add or subtract them because they're not like, but we can multiply them. This actually would be 6x cubed. So see, they don't have to be like first. So we have to remember that don't simplify them first. They will already go together if you're multiplying them. So you're going to multiply the outside numbers by the outside numbers, and you're going to place that value outside. Then you're going to go ahead and multiply the inside numbers by the inside numbers and place the value inside. Okay, and then we're going to simplify if possible. All right, so here we go. So in number 1, because our operation is multiplication, we go ahead and we multiply automatically. So the outside numbers are both 1, and 1 times 1 is 1, and we don't need to write it. But the square root of 5 times the square root of 20 is the square root of 100. And we know the square root of 100, hopefully, is perfect, and so that gives us 10. All right, next one up. No outside numbers again. Technically, they're 1s, but 1 times 1 is 1, and we don't need to write it. We have the square root of 10 times the square root of 5, which is the square root of 50. 50 is not perfect, so we're going to go ahead and have to break it up into the perfect. Remember, our perfects are 1, 4, 9, 16, 25, 36, 49, 64, and they keep going, okay? For 50, the largest perfect that goes into 50 is 25. So 25 gets the first radical. 2 would be the other, right? 25 times 2 is 50. So square root of 25 times the square root of 2 is square root of 50. Go ahead and circle the perfect that was off the list, and that becomes 5 square root of 2. Okay. Next one up does have an outside number. It's 4, and the other one is 1, and 4 times 1 is 4. Square root of 3 times the square root of 6 is the square root of 18. And square root of 18 is not perfect. So we're going to find the largest perfect that goes in, which is 9. The other number is 2. Circle the perfect, and that's going to become 3. And we end up with 12 square root of 2. Okay. Number 4. Outside numbers, 2 times 3 is 6. Square root of 2 times the square root of 6 is the square root of 12. 12 is not perfect, so we're going to find the largest perfect that goes in, which is 4. The other number is 3. Circle the perfect. Square root of 4 becomes 2. And our final answer ends up being 12 square root of 3. Okay, next one up. Okay, so 3 square root of 5 all squared really means 3 square root of 5 times the 3 square root of 5, which ends up being outside numbers multiplied. 3 times 3 is 9. Square root of 5 times square root of 5 is square root of 25. And since 25 is perfect, we circle it, and that's 5. Bring down the 9, and 9 times 5 is 45. Okay. Same thing with the next one. 2 square root of 7 squared means 2 square root of 7 times itself, 2 square root of 7. Outside numbers multiplied is 4. Inside numbers multiplied is 49. 49 is perfect. Square root of 49 becomes 7 times the 4 is 28. Okay. So that's how we multiply radicals. Not too bad. All right. Number 7 says determine if the following side lengths can be the sides of a right triangle. Because they said right triangle and they said side lengths, we have to know by now that it's a squared plus b squared equals c squared. When we use the Pythagorean theorem, remember that c is the hypotenuse. And that the hypotenuse is the largest side. When these are in radical form, we don't know which number is the largest side. So we have to type them in our calculator to figure out the decimals of which one's the largest, okay? So if we to go ahead and type in, well, 3 is just 3. So we don't need to type that one in, okay? But 2 square root of 2, if we grab our calculator and type it in, you're going to see that it's 2.8-ish. And so we know 3 right now is the largest, okay? But it's not just 2.8, it's 2.8-ish. I just didn't write all the decimals. So you have to remember that you can't use 2.8 because that's not accurate. It's not exact. Square root of 17 ends up being like a 4.12 ... Okay, again, it's not just 4.12, so you can't use that to be accurate. All right. And so now that we can see that right here, this one is our largest. So that has to be our C. All right, so we'll go ahead and plug in, and we're going to have 3 squared plus, now you got to be careful, it's 2 square root of 2 is the side, and you have to square the whole thing, equal to square root of 17 squared. Okay, 3 squared is 9, plus, if you go back to that decimal that you had in your calculator, and you grab it and you square it, that ends up being 8. Okay. And if you go back and grab the decimal that represented square root of 17 and you square that, that's going to be 17. And the reason why that one is because the square root and the square just cancel each other out. Why it doesn't work here is because of the number in front. You have to make sure that you square that number out in front, okay, like we did up in number 5 and number 6 up here. Okay, all right, go ahead and add them together. 9 plus 8 is 17, and 17 equals 17. And so can these be the sides of a right triangle? And the answer is yes. Okay, all right, for the next one, again, we don't know which one to put in for C for the largest because that is the one spot that does matter in the Pythagorean theorem. So we got to go ahead and we got to figure out of these radicals that we were given, which is the largest. So we have 2 square root of 3, and 2 square root of 3 is about 3.4. ... Okay, 3 square root of 2 is about 4.2. ... Okay, and 4 square root of 5 is 8.9-ish. ... Okay, and so now we can see that the largest one is this 4 square root of 5, and that has to go in for C. So when we go and plug into the Pythagorean theorem, we can put 2 square root of 3 in for A, squaring the whole thing, so make sure you use parentheses. 3 square root of 2 can go in for B, and 4 square root of 5 has to go in for C because it's the largest. Okay? In your calculator, you can go back up and scroll and grab those decimals and square them. Okay? This first one ends up being 12. Go back up, grab the decimal, square it. Okay? This is 18. You can go back up, grab the decimal, and square it. Okay? And this one is 80. If I add 12 and 18 together, I get 30, and we can see that 30 is not going to be equal to 80, so we slash our equal sign, and our answer to our question can be these be the sides of our right triangle, and the answer is no. Okay? All right, I'll see you guys on the backside of notes.